Algebra 2, what do we call this? Practical money math test review, I guess. This is lesson 29. Find the interest earned and the future value. There you go. Future value of the annuity with the annual payments of $1,200 or $1,200 for 15 years and an account that pays 4% interest. So, no, you're looking for the future annuity value of an annual payment of $1,200. Okay? So you're looking for AF. So I'm going to say AF is equal to $1,200. And what was the percentage of that? Where's it? Oh, 4. So 1.04 for 15 years. Is that our formula? What's that going to tell us? What would that tell us right there? Is that an annual payment? No, that is a one-time. I'm going to put it in there and I'm not going to touch it. Okay? Wait, and I put 12,000, not 1,200, sorry. Exactly. So that's not our correct formula. AF is what? Reoccurring payment times what? This is that part you were supposed to know. 1 plus I to the power of n over I. Good. Now you know the interest, you know the payments, you know the years. Now we just plug it in. So we'd have 1,200 times what is 4% over what would we do there? How are we going to figure out what is our I? Sorry. What is I? Over 15? You said like 6 different things. What's happening? How often are we doing it? Per year, right? So do we have to divide our interest by anything? No. That's like our that's our easy one there. So it'll be 1.04 to the 15th minus 1 over 0.04. Right? Now, when you do that, you should get something. You need to be practicing it tonight. If you don't do anything else, at least go home and practice putting these into a calculator. Because these are not simple just to put into a calculator and get the correct answer. You'll get an answer, but it won't be correct. Because your calculators, as smart as they are, sometimes they have a hard time figuring out what you actually want them to do. Okay? I don't have the charger. Sure. Okay? So if you do this, you should get 24,028. Now you think, well, that's a whole lot of money. Did I round it? Let's see here, 31 cents. Okay, that's how much is going to be in the account after 15 years, right? But how much interest did you get? How are you going to figure that out? You've got the total, so what do you need to subtract? You don't know the interest. You're figuring out the interest. So what else would you subtract? How much you put in, right? Yeah. So you would say 1,200 times 15. And I don't know if I have that. Did I write that down? Yep, $18,000. Okay, so now I got to subtract 18,000, and that gives me a total of $6,028.31. So in 15 years, the bank basically gave you $6,000. Okay. All right, so you should be able to do almost the exact same thing here. The difference with this is what? What's the difference? Find the interest earned and the future value, blah, 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 with a semi-annual payment. So what does semi mean? So what does that mean? Every 6 months, you're making a $1,000 payment. Okay. You should be able to do that. Same thing right here. Same thing as we did right here. Okay. Let's go ahead and go to page 2. Now, page 2, we're, buying an engagement ring. Poor soul. All right, this is lesson 30, and it says Gerald wants to borrow $12,000 in order to buy an engagement ring. Now, in America, you're supposed to borrow 2 months of your salary. So, I don't know, is that a thing in Korea? You can go to the bank and borrow any amount of money if the bank will give it to you. So, like if my salary is $2,000 a month, then I would go and borrow $4,000 from the bank and buy an engagement ring. Or I would spend $4,000 on it. What else do you get a salary from? What do you mean? The amount. The amount of your salary. I tell them, I need this much money. I go to the bank and say, I need to borrow this much money. Because that's just kind of the unwritten rule is you spend 2 months' salary on the engagement ring. Is that a thing in Korea? Well, if he's supposed to borrow 2 months, he gets how much a month? So apparently he makes $6,000 a month. So it'll be about $72,000 a year. Okay, so let's do this. He wants to repay the loan by making monthly installments for 2 years. If the interest rate on the loan is 9.5% per year, compounded monthly, what is the amount of each payment? Now, so we're trying to find what? What is that called? What do we call that? In our formulas, that is recurring payment. That's big R, right? We're trying to find big R. Now, we got 2 different formulas we can use for finding big R. So let's just write the original one. What is the amount he wants to get? He wants it to be $12,000 in the future, right? He doesn't want to borrow because he wants to spend the same amount each month so he can pay $12,000 at the end. Okay? So we're going to have 12,000 is equal to R times 1 minus 1 plus 0.095 over, he's going to do it monthly. For 2 years would be minus 24 over 0.095 over 12, close parentheses. Okay, now the other formula is simply where we take the denominator, multiply it by the amount, and then divide by what's in the numerator. Okay? Which is the exact same way you would solve this. You would solve by multiplying by 0.095 over 12. That's going to cancel. Multiply this by 0.095 divided by 12. And then you would divide by 1 minus, 1 minus 1 plus 0.095 over 12 to the negative 24th over, that's all we divide by. That's it. You see? It's the same thing. You're just kind of skipping a step. Okay? And you would divide this side by 1 minus 1 plus 0.095 over 12 minus 24. And you should get something around the neighborhood of $550.97. Now, if you're buying a $12,000 engagement ring, that thing is a chunk. That's a big old ring, or it used to be. All right. But that's the formula. Or you could have done the R equals API over 1 minus 1 plus I to the negative 24. Up to the n, sorry, negative n. Could have used that one. That's the one that there's two different ways you can solve that one. Either use the R equals or use the AP equals R, blah, 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 and then solve for R. Either way. This one, shortcut. Yep. Well, you could have written that as 9.5 if you move the decimal 2 places, because it's a percent. So now it's 0.095. You don't work with percentages normally. I mean, you could if you want to keep typing percent in every time, but you just normally don't do that. Okay. Page 3. This says, suppose you currently have one credit card with a balance of $10,000 at the annual rate of 24% interest. You have stopped adding any additional charges to the credit card and are determined to pay off the balance. You have worked out the formula, where B is the initial balance, B of N is the balance after you have made N payments. R is equal to 1 plus I, where I is the monthly interest rate, and R, capital R, is the amount you're planning to pay each month. What is the monthly interest rate? I. And what is the growth rate? R. So we would have to say, what is the interest rate? It was 24%, so 0.04 divided by 12, right? Because that's monthly. So this one looks tricky for some reason, but it's not. So, well, sorry, I got ahead of myself. So I is equal to 0.02, but R is going to equal 1.02, because remember, R is 1 plus I. Okay, so there's your I, and there's your R. Now, how long does it take to pay off this debt? If you can afford a payment, if you can afford to pay a constant $250 per month, so that is our reoccurring payment, right? How long will it take? So we've got 10,000 is equal to, no, let's not do that. 10,000. This is our born, B-O-R-N, right? The original times 1.02 to the N, that's what we're trying to solve for, minus reoccurring payment of 250 times what? 1 minus R over 1 minus R, and this is to the what? What's over here? We got to put our N here too, right? That's our problem, is we have the two N's. It's not really a problem, but we can't solve, because that's what we're going to have to log these, right? And y'all remember how tricky these are? Are y'all ready to do this one? Pay attention. Yeah, because we want to give the answer in month and year. So we're going to find how long it's going to take to pay back $10,000, right? Everybody see that? Paying back $10,000. And this is one, if you're not working these out, you're going to have a very hard time of solving these, okay? Because they are tricky. And I'm going to try my best and not mess this up while I'm doing it. That way it will not be as confusing. But I promise you, if you're not working these out, if you didn't do these on your homework, or if you haven't done these consistently, you're probably not going to know how to do this. Let me find this one. Well, anybody know what this one was on your homework? I'm sure it was part of your homework. I doubt I would have pulled it from anything else. I'm not. Because if you figure out the N form, or if you want the N formula, do we have everything we need to know for the N formula? Where that came from? We do have small r, yeah. All right, so I don't know where I grabbed this problem from. Was it a Part of the classwork? No. Okay. All right, so you want to use the N formula? Oh, it'd help if I was looking at the right problem set. No wonder. I won't look at the right homework. All right, so what is the N formula then? All right, so this is our Born formula, minus R, all that type of stuff. N is equal to what? Big R, little r? Gotta be specific on that. Big R over. So what is that? Oh, okay, we'll go ahead and just write it first. BO, and then what? Okay, denominator. Now what? One BO minus one times what? I'm not following you. Let me look at my formula. Wait, this is less than 31, right? That's why I couldn't find it. Yeah. Okay. Plus R all over. Like this log R, little r. And we have big R, we have little r, we have the original. Okay. Yeah, so we can just do that. So N would equal log 10,000 over, no, R is 250 over 10,000 times 1 minus, what is little r? 1.02 plus 250, and then all that over 1.02. And let's plug that into the calculator and see what if we can get the correct answer. Anybody do that? Either way, you can set those up. Whichever way you want to. Sure, excuse me. And you'll have the answer. We're in should be, look at this here, about 87 months. Oh, not 87, about 80, 81.27. So what's going to end up having to happen is you're going to pay For 81 months, you're going to pay $250. And then that last month, you're only going to pay 0.27 times 250. That'll be the rest of the payment. See that? But if you can't plug these in, guys, I'm telling you, there's basically going to be 5 questions on this test tomorrow. And if you can't get the right answers by plugging them into the calculator, setting up the formula, plug them into the calculator, bye-bye math grade. 5 questions. You have 1 question from each lesson. It takes so long to do these problems if you actually worked them out. I mean, if we were to actually work this out by hand and do it, it would take a while. All right. This is just the last step